you know, the study of user interface design and human-computer interaction goes back to the beginning of the invention of computers. And over the period of time, we have evolved a number of tools, what are sometimes called wimpy tools, Windows icons and pointing tools. And what I find interesting is why we have not paid a lot more attention to make human-computer interaction almost the same as human-human interaction. We don't point at somebody and touch their chest or something. We just talk, you know, that's all we do. When we want to, mic closer, okay. When we want to interact, the only interaction we have is speech-to-speech interaction. Human beings only communicate with, and somehow that aspect of user interface design has not gotten as much attention as it might, but I'm hoping in the future, because speech recognition is now fairly well established, and in the future we'll see more of it. And in particular, to make this case more strongly, I want to kind of bring to you the attention of the fact that roughly 3 billion people right now are second-class citizens. They're not able to use our technology because either they're illiterate or semi-literate, even if they can read it and so on. And they are not benefiting from the advances in our technology. And you might say, they don't need it. Computers are for people with PhDs and educated people, but all these others, they don't benefit from it. That's not true, it turns out. If I was an illiterate person, and if I could have the benefit of the use of information technology, I would actually benefit more. You know, in AI, we have this concept of designing intelligent assistants. That will help you to do the things that you want to do. And many of us have an assistant or a secretary in our office, and we use them to do things that we know how to do, but they're routine, and we can delegate it to somebody else. So if you think about building an intelligent assistant, where you can delegate, saying, all the way from get me a cup of coffee to get me, the president, or get me an appointment with so-and-so. All of those things, we just delegate. Now, when we delegate, what happens is, this other person is intelligent enough to figure out what has to be done to make it happen. This is what we call in AI, what-to-how programming. Most of the interaction is only with what you want to be done. The how of the programming is all done by the assistant. And the whole technology of what-to-how programming is where the new science of intelligent assistants will be proceeding, and there's been a lot of interesting issues of what does it mean if I said, get me the newspaper, or get me a summary of the news items today, and so on. So, with that as the kind of background and information, I want to kind of talk to you about the special problem I've been thinking about it because I come from a little village in India What do we do for people at the bottom of the pyramid? There are about 3 billion people of that kind. Next slide. That one? Oh, I see. I was pressing this. Good. Okay. Oh, there. Okay. So, what is this bottom of the pyramid? I have to look at the slides on the screen because here it's so tiny. So, you can see about 3 billion people at the bottom of the pyramid.
Dr. Reddy, we can't hear you.
You can't hear me. Okay. How's that?
Better.
Better. Okay. And they have some interesting characteristics. Their income is less than $1 billion and $3 a day, and about 1 billion plus are illiterate. They can't read or write any language. Most of the people at the bottom of the pyramid cannot read or follow directions, read newspapers, and can't use keyboards and touch-based computing apps. The only acceptable mode of interaction for them is what they do with human-human interaction, speech. And even in speech, it is not as structured and as well defined as what we make most of our user interfaces. You simply give a vague, ambiguous, arbitrary command, and they make it happen. Okay. The next slide, please. I hope I don't fall off here. Okay. The interesting thing about the human race is everyone can hear and speak, but they may not be able to read or write. If you cannot read or write today, then there are a lot of things that even an illiterate person might benefit from that they can't do. They can't read a Wikipedia, they can't watch a foreign language movie, or listen to Khan Academy lectures for elementary school and primary school, or order food supplies online from Amazon or some other online vendor, or things like vote online and many other things that are beginning to happen. Computers and smartphones capable of speech-based interaction are essential for the Dutch population. If they can do all those things using speech and with low-cost smartphones and emergence of Siri and Alexa, voice-only dialogue interfaces become possible to think about. When I first saw Alexa in 2014 or 2015, I said, this is what I've been waiting for 30 years. Basically, one of the things about Alexa, except it is not mobile, is you can speak, you don't have to face the person, you can speak anywhere in the room. With beamforming technology, with multiple microphones, it's able to recognize and understand. And it can carry on a dialogue, it will execute your command, all kinds of things. Only, there's no keyboard anywhere, right? It's only with the thing. And so now, if those technologies were available for people at the bottom of the pyramid, they would become first-class citizens. They can do all these things. And it turns out, so I have a request. Many of you are faculty members and many of you or will be faculty members soon. And these are all projects that I would give to a master's student, saying, okay, you need a thesis topic, here is one, I want you to be able to do entertainment and education on demand. And same is true for all communication, reading newspapers, banking. You know, take, in, for example, banking. If you're an illiterate person, when you go to the bank, they'll give you a form and say, fill it in. You can't read it. So what do? The question is, what is the nature of the user interface where I am given a form and my intelligent assistant looks over my shoulder, perhaps it's a Google Glass or something, reads the form, and it already knows many of the fields, you know, what is your gender, how old are you, and what is your date of birth, all of that it knows. It will fill all of that in. And you see that now in many of the interfaces, you know, they automatically will fill in your address and your banking information, credit card information, which is great. You know, that's exactly what should happen. And my advisor, John McCarthy, used to say, one of the fundamental laws of AI is you should never ask a person, the computer should, for which it already knows the answer, has been given the answer once. How do you design a system where you only ask each question once, no more than once? And that becomes a very interesting challenge. You know, that means you have to have a lifelong learning, lifelong knowledge acquisition system that is actually providing you with these types of things. Okay. This is how a human-computer interaction would look like.
Good morning, Kate. It's April 1st, 1997, and the time is 6:30 a.m. Kate News Selection reports new trade agreements between Japan and France affects Paris spring collections, plus 24 other items of interest. Care to browse?
Not now. Mail only, please.
Mail serve here. 43 items, including 26 unopened for 3 days, 12 unopened for 2 days, and...
Cancel list. All right. All right, I've been busy.
Canceling. Were there further instructions?
Yes, did my Snap catalog arrive?
I understood catalog. Snap. Checking.
All right.
Enthusiasm detected. Care to view large screen?
You bet.
Did that mean yes?
Yes. Switch to large screen.
Incoming VidPhone call. George Smith from Snap Headquarters, Priority 1. You wish to preview Mr. Smith.
Darn.
You've used that before. Do you care to define it?
No, hold call, preview caller. Oh no, I smell trouble. Ugh. Okay, VidPhone, open connection.
Kate, are you there? I'd rather see you, Kate.
Sorry, George, not exactly dressed for success this morning.
Seen the customer version of our spring catalog yet? Huh?
Yeah, I just got it in the mail. You guys don't exactly waste time.
You did one heck of a job, Kate. One heck of a job. I love that history of the T-shirt segment. Wonderful. Sales are up.
Hey, cut to the chase, George. You didn't stay up all night to call and compliment me.
Kate, you are the best interactive designer in the biz. I mean that from the bottom of my heart. But I got a little emergency here. You know that blue jeans spectacular that you're working on?
Did you know that blue jeans were invented during the gold rush? A major moment in American culture.
Look, I know that your due date was next week, but I gotta move it up.
Don't do this, George.
I need it by today, 5 p.m. We're going into production tonight.
Tonight?
Orders from the top. I mean, our competition is breaking early. They're doing a genes retrospective, too. We gotta be better. We gotta be first. The future of Snap depends on you, Kate. Oh, and there's something else.
You're changing the concept on me, George.
Oh, Leland, we gotta take the history of our blue jean story into the future. End your segment with a forecast of the jeans of the future.
No one can predict fashion, George.
If anybody can, you can. Come up with something, champ.
VidPhone, get me Sam Gallagher. Try every number. Copyright status?
James Dean image unavailable. Copyright Paramount Studios. Last usage granted at $15,000 to Levi Strauss for in-house promotion, one time only.
Darn.
Alternate suggestions?
Yeah, let's see. Image search, circa 1959. Blue jeans, male, sex appeal.
Searching Nexus. Access other databanks.
Picture perfect, fashion source and alter image.
You asked to be reminded. Search on Alter Image Databank is very expensive and likely to exceed your monthly online budget. Cost is $4.85 per 1,000 image scan.
Just do it. I'll fight that one later.
Searching. Did not understand last command.
Do it, do it, do it.
Understood. Kate, still unable to reach Sam Gallagher. However, the teleconferencing call you requested is ready. Have Snap Corporate Los Angeles and Paris office both online. Do you wish to be seen?
Yes. Preview.
As originator of the conference call, do you wish to choose resolution on live video?
Whatever.
Default settings confirmed. You asked to be reminded, full video from Paris is expensive at $3.55 per minute. A call of less than a minute will exceed your budget of...
Got it. Top resolution on George. Face only on Genevieve.
Understood. Conference call open.
So this video was made 30 years ago, slightly over 30 years ago. It's longer, like 16 minutes. I'm only showing you a little snippet. And it has always kind of intrigued me under what conditions would be able to do all those things. Every interaction, dialogue interaction, poses different problems that we had not thought about. Every one of them. And so the first thing I noticed is we're assuming specialized agents, intelligence assistants. One reads your email, another reads your something else, and they're all kind of telling you what you need to know, like paying the bills. And we seem to be able to act on those things, you know, and we do this normally every day with our secretaries and assistants. We have no problem, but it turns out what I want to do, is kind of point out, go into the detail of some of these things. So I'm kind of starting with the assumption I want to help people at the bottom of the pyramid. And for that, I'm assuming all of them will have a smartphone. On their smartphone are a set of apps, personalized intelligent assistants, that will actually provide the support they need. And I'm saying this will happen because of the cost of computing and cost of systems are going down. We can come back to it, and language divide and literacy divide limits the access to the internet-able solution. Providing the right information to the right people in the right language at the right level of granularity turns out to be very important for everyone. The question is, what is the nature of intelligent assistance I can build that will be able to do that? That's a different talk I give on how would you predict and deal with tsunamis and hurricanes so that we don't have as many people dying. You know. So sustainability and affordability are the two very important attributes for the people at the bottom of the pyramid. So there are a bunch of necessary conditions, if we're going to assume that. We need infrastructure, smartphones, and we also need information about people, places, and things. We also need access to computing power, memory, and bandwidth. We also need lifelong learning systems. So if you go back to the video we saw, there were a whole bunch of assumptions that were there, and what we need to be able to talk about are the user interfaces for the people at the bottom of the pyramid. They need to process, index, and store, retrieve relevant information, capture, remember, and learn from experience, share knowledge with a community of other agents, and learn from own experience and learning from experience of the others, and exhibit goal-directed behavior, tolerate error and ambiguity, and operate in real time. This is the definition of AI. What is AI? If somebody asks you, we'll have AGI in the world, you kind of say, can it at least do any of these? This is not my definition, it's Alan Newell's definition. We used to debate about what would constitute intelligence. And we had these 6 or 7 attributes: use knowledge, operate in real time, use symbols and abstractions and so on, tolerate error and ambiguity. And most systems that we have today, AI systems, even large language model systems, don't do all these things. They do some of them, but not all of them. Human beings do them all. That's the wonderful thing about human. So that's where the target is, target goal is. So first thing I'm assuming is these agents should be able to see, hear, and interact. We have systems that are beginning to do speech recognition and image understanding reasonably well, but I'm not yet sure that if they came into a conference room like this, they can see, hear, and interact as other human beings would. So the problem I face here is this video assumes, it says, good morning, Kate here, and good morning, Kate, and it kind of says, it's April 1, 1997, time is this, and goes on like a human being might, a human assistant might tell you if they were properly trained. So you then say, well, I'm not going to go into all of those, just mail only, please. And then mail serve. There's another intelligent agent, not the same one, says, oh, I looked at your email, and there are a bunch of unopened emails, and a bunch of been there for a long time, and so on. And at some point, this is what we call mixed initiative dialogue. Normally, you're asking it to do something. Suddenly it says, well, do you want me to do anything else? And there's a change of direction, and snap catalog arrive, and then the system doesn't necessarily understand it. It needs to have a clarification dialogue to kind of deal with it. And so the whole issue of how to build dialogue agents that can do those things. There are a whole bunch of other things. Such dialogue agents must be self-aware. It said, enthusiasm detected, you know. Do you want to view the large screen or something? Be aware of emotions. And this is one of the things I've always been curious about. How does a person know what they do not know? How does an agent know what they do not know? And so you have to kind of come back and say, I didn't understand the last command. So you said, well, don't worry about it, get on with the job. And the last one is still very, you know, we don't know any dialogue system that I know, or AI system that I know, that can learn with experience. So we're having a dialogue. Suddenly I use a word that you don't understand. You say, I didn't understand the word. What does that mean? And you tell me, and then I'm able to internalize it, and then from then onwards, when I hear the same word, there's no problem. No problem. And so, so the issue of, you've used that word before, darn. It doesn't know what darn means, and said, do you want to define it? So there's an implied capability of an agent, where if I can define a word, it can learn that word. And that also assumes I know how to define a word, darn. Most human beings don't know how to define the word they use. They would kind of give a vague description. And that's good enough. You know, the interesting thing about the human-human interactions are, they deal with error and ambiguity all the time. They don't ask for precise definitions. And so, what else? A dialogue agent must also remember and prompt at the right time. This is where, you know, a good assistant will tell you you're going to run out of your budget, or there's some problem that with what you wanted to do. I did this other alternative thing, is that okay? So there are many things that your office assistant will do that we don't yet know how to do in the systems. Okay? Provide the right information in the right language at the right time, in the right level of granularity. This, my colleague Jaime Carbonell coined this phrase, AI Bill of Rights, of 5 rights. Provide the right information to the right people in the right time, in the right language, in the right level of detail. So if you're about to be hit by a tsunami and you need to get into high ground, like it happened in 2004, Indian Ocean tsunami, you can't go into details of how tsunami worked and what happened and all of that. You just say, get to the high ground right now, okay? So the right level of detail turns out to be very important. So this whole set of issues on AI Bill of Rights become central to building intelligent assistants. Okay. Offer right advice in the right context. I'm saying all these things, I hope you're taking attention, because these are all user interface issues, ultimately. And user interface design includes within the scope all of AI, all of computer science, everything else. So it's a big, big problem to get the user interface right. Right advice at the right time. Okay. So there are a whole bunch of other implied assumptions that your agent that you're designing must have. And these are very important. I'm assuming these agents are like, you know, human beings, they're able to talk to each other, learn from each other, so that their learning happens very fast. If anyone anywhere among the society of agents has done this problem, if you can have access to it, you don't need to ask them. This is where the what to how programming becomes very easy if you have a society of communicating intelligent assistants. Somebody somewhere would have done it already. And that's why the large language models work. Even if it's a very rare event, some person among the 7 billion people would have used that language at that time, and therefore it becomes reasonable to think all of that is now encapsulated in the large language model. Share the knowledge among these assistants, persistent knowledge bases, real-time response, mixed initiative dialogue, where you might ask it to do something and it might come back and say, I'm sorry, the call you wanted me to make is now waiting, can you talk to that person? So that's where we get the goal-directed behavior of user interfaces. How do you design goal-directed behavior? But the biggest problems, of course, are privacy, legal, and security. If all these agents can share the knowledge among each other, maybe they're giving away some of your secrets. How do you, what is it that you want to protect? What is it that you're willing to share? This becomes even a bigger problem than user interface design. It turns out if you had monitoring systems globally that can tell you about who is infected, then you can just quarantine them and not kind of shut down the whole city or the whole country, as happened at the last pandemic. But the problem was, how do you make sure your privacy and security are preserved? And by appropriate anonymization, it is now possible to do some of those things, but there's not a general acceptance in the society of privacy of individuals and other participants, how it would be protected. Even if you say it's anonymized, therefore your data is protected, your name is protected, they may not believe it. How do you prove that this is something that's worthy of doing? Okay, there are a whole bunch of other things here. I'm not sure I want to, how are we doing for time? Okay, maybe 10 minutes? Okay. So it turns out, if you think about what is involved in designing these personalized intelligent assistants, why is this important? Because I'm saying in the future, the other 30 billion people, 3 billion people, would also join the community, and they won't be able to read and write like the rest of us do. And we need to think about how to design user interfaces that will also, it's no different than the current research in accessibility. When you're designing a system for someone who is deaf or hard of seeing or blind, and we make appropriate allowances. The largest disability is not being able to read or write. Right? You may not be deaf or dumb or blind, but you can't read or write. Therefore, many of the things that we take for granted are not available to them. So the architecture is very interesting if you think about what is involved in an intelligent agent architecture. It must be always on, always working, and always learning, lifelong learning. How do you design such a system? Right now when I have a smartphone, I have to touch the app to make it do something. I don't want to touch the app. It should be always on. always working. And it should monitor, analyze, and learn from experience, and automated discovery of data and information sources. This is very interesting. If you're willing to monitor and analyze from experience, where should you look? Where is it going to be? And this automated discovery of information sources, how do we do it? When I want to find something, I do a search and go, see the results from my search engine, and then do something. And can an agent do the same thing? And how does it work? Okay. So it turns out, in addition to being illiterate and not being able to read or write, another major problem we have is the language divide problem. Many of us may be educated, but we may not be able to speak each other's language. Today, we now have technology where you can translate from any language to any language. The only problem is, most of the speech-to-speech translation, which is what I'm talking about, is only working for about the top 10, 20 languages. There are about 100 languages which are spoken by 10 million people or more. And I'm kind of saying we need to make all of those languages first-class citizens. I call them orphan languages, 90 of them. And the reason they're orphan is we need data to train the language models. And the language models for Swahili and Marathi may not exist, and in which case we need to find a way of creating those language models. Okay. So it turns out semi-literate population will be the biggest source of speech-to-speech interactions in the future. And the speech-to-speech interactions of semi-literate populations, they all use WhatsApp. If you go to any of the developing countries, they all use WhatsApp. Even an illiterate person is using and talking in their language. Right. The problem is, right now, that data which could be collected and available is not made available because it's private dialogue, and I don't want everybody else to listen to me. But it turns out there are ways of anonymizing spoken language dialogues that would be essentially impossible. You can reconstruct the original dialogue, but it will take 1 million years of 1 million computers doing it. And so the technology for anonymization is there, provided society says it's okay to monitor all the conversations of everybody on the planet, except you have to immediately anonymize it, and except you have to immediately fragment it and reorder it in such a way it will take 1 million computers 1 million years to get the reconstruction. So existing technology can create compelling apps and all these things, entertainment, e-commerce, banking, are all there. The question is, can everybody on the planet have one of these things? My answer is yes. It turns out, right now, at the last COVID pandemic, the world lost 15% of the GDP. 15% of the GDP of $100 trillion is $15 trillion. If you give every person a smartphone for free, That'll only cost like 10% of the loss of the last pandemic. And so I'm proposing we should think in terms of digital infrastructure, just like we build roads and water supply systems and other kinds of things because the society needs it and we don't ask everybody to buy it. So the issue of digital infrastructure, where every person is guaranteed to have a smartwatch and a smartphone, and so that we know we can reach to every person. This becomes very important to get the right information to the right person at the right time. And so there are possibilities for the future of society that I am imagining that they may not happen in my lifetime. I certainly hope it will happen in your lifetime. And the real problem there is solving the anonymization and privacy problems. If you can guarantee privacy and nobody can reconstruct my conversation with my friend, then I think we'll be, this will, I think, increase, if everybody, you know about the Metcalfe's law, about the power of the internet or the connection increasing as the square of the number of people connected, right? And if we double the number of people connected from 3 billion to 7 billion, and now all of a sudden we have 4 times as much wealth. On top of that, connectedness leads to other value-added services. So my kind of prediction is by 2040, 2050, we will be a $1,000 trillion economy. Not today we are $100 trillion, by a factor of 10. And most people shake their head and saying, "You're not an economist. You don't know what the hell you're talking about." That could be. I tend to be an optimist. If that is the case, then these intelligent assistants will pay for themselves. You should just give everybody and make sure that we have a globally connected infrastructure, what I call the word connected world. Everybody is connected. People, places, and things are all connected. It is more than just connecting the people. It is the IoT of the world, right? So in conclusion, the 3 billion semi-literate populations of the world are a major untapped market for the IT companies. Creating voice-based intelligent assistants like Siri and Alexa using speech technology is only the option to support their needs. We have the needed tools and technology, and we need to figure out how to do open source sharing of language models of all the 100 orphan languages that are currently not available to the people. Thank you very much.
Yeah, so if you have questions, you can come to the mic. There are 2 mics on this side and 1 on either of these sides as well.
Shumin Jai. I work at Google. Thank you for the very inspiring talk. Interestingly, what you proposed is not only what the bottom 3 billion people want, but everybody would want that, having an all-powerful kind of voice-based agent that can help you to interact with technologies and make use of technologies. So many of us at Google are thinking about this, and arguably are working on it. I would say that right now, the challenge is already mentioned in your talk. The biggest challenge is privacy. That's not to say we have known all the technical obstacles to achieve that, but the even more of a pressing challenge is that how could you do this privately? And it's not very clear at this point that that's actually achievable. That is, if something knows that much about you and learns so much about you, you as a user, would anyone be comfortable with that? And yet that system is not ultimately controlled by one company or one agent, one agency, which is a problem. But if it's not controlled by anybody, that's also very unnerving. So that is something we kind of struggle all the time. And arguably, that's the biggest obstacle right now. But that's not to say the technical sides are still a lot of things that we need to work on. That's how we feel today. Yeah.
Yeah, so the main concern is privacy and policy around it, like the technical challenges are sort of already being addressed at a
So one thing I think we can all agree, if we had a smoothly working voice interface, it's not just the people at the bottom of the pyramid, everybody would use it. Because it's so-called principle of least effort. If I don't have to type and if I can just assume, I can say something and it'll happen and it'll work. The anonymization problem, I've been working on it because I think having systems that monitor everybody and everything, all the people, place, and things on the planet all the time, and processing the information, we can do a lot of good. And so what can you do about the anonymization? One is, I think Google is already doing it, or Apple is already doing it. There's nothing that says, just because you collect the information, nothing that says it has to be available to everybody immediately. So there's the issue of these systems, our smart watches and smart phones are becoming, will have a terabyte of memory, so a lot of things can be collected and not shared. And if I'm a public health agency and I need access to some of your data, I can request. And if there are appropriate anonymization guarantees, and there are anonymization programs, I can share my data, and the exact sampling problem has to be defined, what samples, at what intervals, and so on. And knowing my privacy is guaranteed. And that is actually possible. So basically, edge computing, or local computing at the edge, is the answer to the privacy problem. Namely, all my data is with me. I own the data. And if anyone else needs to access it, we need to have a dialogue and share it. If the government needs it, or public health office people need it, there must be some special provisions made for it. Like it's no different than census data. Right now, there's a lot of information collected in every census every 10 years, and it is anonymized and made public, and in smaller samples, not the entire data, but smaller samples of census data is available to anyone that needs it. In that sense, I think it'd be a great thing.
While people are thinking of other questions, I have a quick one. So one of the things is that a lot of computer science instructors, especially the ones who are teaching the intro to programming courses, are really concerned with the advances in large language models and how things like Google Copilot is able to sort of like answer a lot of things, right? And programming in a way is sort of becoming obsolete, and some people are trying to solve that, and some are saying it's not a problem we need to solve. But as you highlighted, that the access to some of these technologies is not uniform. So a lot of people in resource-constrained environments will not have the same AI abilities and things. Do you believe that, what are your thoughts on the fact that we will have these differences in access, and that would also lead differences in training. And maybe the next set of really advanced software developers might actually come from those resource-constrained environments because they don't have the tools that maybe some people might believe is going to slow down their learning.
Yeah. So there's no question ChatGPT and GPT-4 based models will do 80–90% of your programming for you. And that's what I mean when I said what to how programming. In the future, we should just state what you want to do and then have the systems do the how. And the how is what the programming is about. Most programmers are giving you algorithmic step 1, 2, 3, and you don't need to do it in the future. All you do is what? And then the question is, what are all the programs that I need to, not programs, skeletons of programs I need to have so I can, when I have a problem, I can specialize it to that particular problem. So I think the future of programming profession will be very different 10 years from now and 20 years from now than it is today, in that we won't be doing routine programming, but we will be creating a lot more what to how type of what is it to be done. And it goes back to the whole idea of functional programming, actually. And where you're doing top-down program decomposition, and the top 1 or 2 layers human beings might do, and the rest of it, because they're kind of, would be done by machines.
We have time for one more question. Yep.
Hi, hello. Thanks, Dr. Reddy, for the talk. I'm Shakir from Meta Reality Labs. You mentioned a lot, and a lot of the focus of this talk is around literacy rates around the world, and not only in America, but also everywhere else. But I think you mentioned there's quite a few. I wonder if there's another way to solve this problem. Instead of relying on, let's say, speech-to-speech voice models and AI models, but solving it in terms of actually reducing illiteracy rates and like increasing reading comprehension scores and math comprehension scores with personalized tutors, right? And because like, even if we do have these sort of speech-to-speech models, you know, the example, one of the examples you gave is of someone having the email assistant and like different things like that, that still is actually quite a bit of cognitive load for a lot of people, even if they had that available to them. So I wonder if the problem can also be tackled in parallel in like a different way.
Solving the illiteracy problem, there is a very interesting experiment that was done. I don't know how many of you are familiar with Learning X Prize. And the X Prize, it was a $10 million prize that was established by the X Prize Foundation with a grant from Elon Musk. The challenge was, if you gave a tablet to a 7-year-old or 6-year-old in a remote village where there's no teacher, no nothing, can they learn enough within 1 year using the tablet to read, write, and do arithmetic at the first grade level? And much to my surprise, 2 groups won this prize about 5, 6 years ago. If you're not familiar with it, it's very interesting to go check up on the Learning X Prize website and what they did and how they did it and how they won it. the thing that kind of caught me was the user interface issue. So here I'm a 6-year-old. I'm given a tablet, and it just looks like a granite stone or something. I don't know what to do with it. It's just there. And how do I then, beginning with that, actually learn to read and write? And what they did was very interesting. They essentially, the people, one of the groups that won, were experts in game design. So as soon as you pick up the tablet, a little icon, a cartoon character shows up and wiggles itself and speaks and saying, talk to me, talk to me. That's in their local language, right? And then you say, what can I do? Who are you? Whatever it is. And then that begins the dialogue, including they don't know that it has to be charged every night. They don't know many things, but you can lead them by the nose. That's what they did, and they built this system which ultimately won the prize. So my answer is the problem to the solving the illiterate people's problem ultimately is not just speech-to-speech. That may be a component of it, but on the other hand, if I'm a lazy person in a village, I say, I don't want to learn all this nonsense. Don't bother me with reading and writing. Just do what I want you to do, okay? And the issue is learning to read and write requires a certain level of discipline and certain level of commitment and certain level of, forcing by the teacher and parents. And if I don't have to do any of that, and this is what the usual question I get asked in AI talk, saying, hey, if AI will do everything for me, why should I learn to go to college or school or anything? I don't want to go anywhere. And so this will be a problem. And my answer is, if you don't go to school, you don't know what is possible. And one of the reasons you need to go to school and understand and read and write is the more knowledge you have, the more options you have. It is there's a book by Deutsch called The Beginning of Infinity. I don't know how many of you have read it. It's a great book to read. What it says is we are reaching an exponential on the ability to explain different phenomena. And as we go on that thing, we will become infinitely more capable than we are today. That is, the abilities we have, even if I have a PhD and all kinds of things, there are a lot of things I don't know. And I was kind of saying, how would I know that? How would I learn that part of biology which I had nothing to, we had 5 Nobel Prizes recently. Many of them went to computer scientists, 4 of the 5, but they were in physics and chemistry. And the things that they did, for example, the protein folding problem. I knew the problem, but the question was, how did they do it? What are the specific, data that they needed to have, how they learned the modules and so on. That would be a very interesting thing, and I would spend a month or maybe even 6 months of my time learning all the knowledge I needed to have in order to build a system similar to that. And that's where I think the motivation, and there's a book by Duckworth called Grit, I think it's called. Unless you have motivation, you can be a genius level in IQ, you're not going to succeed in life. And so,
Thank you.